So binomial case, we only have two possibilities. General cases, we have more than two possibilities, okay? So we can still calculate multiplicity of something when we have more than just two outcomes. And in this case, we have T number of different categories, and then N is the number of objects that fall into category T, okay? I think it probably makes sense that binomial case is simply a general case when you only have one and two things. There's just two options, so I'm cool with however you like to memorize using these. If you have really old slides, I've been good about it the past couple semesters, but if you have really old slides, you may have omega being used instead of a capital W. You might also find that online for multiplicity, the omega. We'll always use capital W. I did get a complaint one time that was like, well, work is W, so I don't want multiplicity to be W. And I'm like, I don't care. Just learn it. So, all right, here's an example. I have 4 bases. How many different ways can I arrange my 4 bases, an A, a T, a G, and a C? So you could write out all the possible arrangements if you want on your page. I probably wouldn't do that. I'd maybe try the multiplicity equation up in the corner. So take a second and try to answer that. What's N? How many positions am I trying to fill? 4. I have 4 categories, A, T, G, and C. And how many bases do I have in each of them? 1, and 1, and 1, and 1. So what is this equal to? The bottom's just 1, so this is equal to 4 times 3 times 2 times 1. There they all are, right? So you could write them all out. This one's still doable. 24 different ways. So an important thing to keep in mind is whether or not you can tell them apart, okay? And the way we'll talk about this is the word distinguishability, okay? I think it follows fairly logically that in this case you would be able to tell A, T, G, and C apart. But can you tell 2 A's from each other or 2 G's from each other? Okay? I will always tell you whether you can or not. Okay? So in this case I have just a 3-mer sequence, AAG. Okay? 2 nucleotides would be considered, or any 2 things, right? 2 dye molecules, 2 whatever they are indistinguishable if I can't tell them apart. Okay? So first, let A and A be distinguishable. Give them subscripts 1 and 2 to make it easy. Write it out. I can organize these as basically GAA, GA2A1, A1GA2. There's 6 ways to do it. Oops. And so my categories are A1, A2, and G. 3 times 2 times 1 over 1 factorial, 1 factorial, 1 factorial. But if I can no longer tell the A's apart, basically now my category of A has 2 things in it. Okay. Take the subscripts off, both columns are the same. You essentially have GAA, AGA, or AAG as your 3 possibilities now only. And so it simplifies to 3. Is everyone comfortable with that? Okay. Not surprisingly, we didn't get nearly as far as I wanted today, but that's okay. Let's do the example on the next slide. It says the left and right side of the room. I mean, pick whatever side you want to do. But pick a side, whichever one you want, and go ahead and calculate the multiplicity. You could do the multiplicity of both, because what you're essentially being asked for is which has the greater multiplicity, and how do you know? Calculate the multiplicity of your particular 6-base sequence. Bases are indistinguishable from, like A cannot be distinguished from another A, but they are distinguishable between different types, okay? So A doesn't equal G, but A does equal A. Treat them like that.